Greetings and welcome, friends. Mr. Waddy here and my algebuddies. My algebuddies are feeling a little bit nervous today, so add some comments below just to encourage them. They're going to do great on this test. They've studied all weekend. It's going to be amazing. And also, I'm sorry, but your comments are too late. I haven't posted this video before the test. That'd be weird. I'm recording this right now, and they're taking the test like right after this. But nonetheless, like you could write something like, "I always believed in you. I'm so proud of you. You did great." So there we go. Here's question 6. They were asking us to find the standard deviation between these two data sets. So the first thing I've got here is x, and the next thing I'm going to figure out is x bar. What's another name for x bar? What do I mean by that? It's the mean. That's right. That was amazing. That was beautiful. So let's see. Let's look at question 6. So x bar is the mean, and in spreadsheet speak, they do generalize and call it just the average. So I've got an average of 190 right here. Yeah, it's a little different, but you guys just follow along the concept. The mean for these scores is 190, and the mean for these scores, I guess, like, I mean, if you think about it, it's like business. Their score is determined by the dollars. So yeah, so they're earning their score, their points. So there's my mean. Okay, so all 233s for the second one and 190 for this one. So 190, copy down, 233, copy down. So just based on that information alone, which store do you think did better? Store B, right? It has a higher average than store A. But now if we want to analyze which store was more consistent, that's when range or standard deviation are going to come in hand. Yeah, it's a little bit different, but I think it's still going to help us because we just need to practice the standard deviation. What's the next column for my standard deviation formula? Yeah, Kaylin. X minus x bar. So what I'm doing here is I'm taking each data point and subtracting the mean. All right, so in my spreadsheet, I'll write x minus x bar, and I'm going to just go to equals this cell and subtract that cell, and I get negative 50 for that one. Drag it down, I get a whole bunch of differences from the mean, and that's what standard deviation is trying to describe for us, is what's the average distance any of our data points are from the mean. All right, is the rough kind of definition. Let me even copy that down here, and you'll see that I get those as well. Now, if I was to add these up, they actually should end up kind of zeroing out, so that wouldn't be as helpful. I won't necessarily copy all of these down, but what you would have done is, right, just entered these in, negative 40, etc. What's the next thing I do? Yeah, Jake? Right, so this column, I'm going to square all of those, which that's actually going to help us out regarding that some of the negatives. All of the negatives will become positive, and then I won't end up having that issue anymore. So x minus x bar squared. So my formula, I'm just going to hit equals. I'm going to select this and square it, which you can do with a little caret symbol there, squared. And so there I get 25,000, like so. And so notice that none of these are negative anymore. So that's going to deal with the problem. Whereas if I tried to average these, they would end up just zeroing out. Let's see. I can also then copy that here. Oh, that looks like that copied incorrectly. Let's see. What's my formula doing? E12. Huh. That's the weirdest thing I've ever seen, guys, right? Are you seeing that? It's claiming that negative 8 squared is 56.25. Oh, you know why? I think I know why. Here, there we go. Those numbers were being rounded to whole numbers. So my actual average here was 232.50. And as a result, I was getting a different output where this one wasn't, so it was displaying something different. So let's see, 750 squared, I think I believe that. That seems like that's the right value. And when I drag that down, that's what I get. So, right, negative 50 all squared. I would enter those in. That's 10, that's 1,500, etc. So I calculate all of those. Now the next one you guys have been asking me about is variance. And all right, question, comment, observation? Yeah, variance is just going, exactly, it's going to be the average of these squares. All right? Yep, the squared one. That's all right. Today's a good day to figure that out. So I'm going to type equals average and select that list. What if I was doing that by hand? What would I do? Or with a calculator? Yeah, how do I find the mean? Add them all up and divide by how many there are. So there's my variance for that one. I think if I copy and paste this, let me just make sure it's pulling all of them. Yep, it works out there. So I get the variance for both of those. I'll write that down here. So variance, 1550, is that what they said? Yep, and 2312.5. We'll go one last. Bam. So that's still not yet the number I'm looking for. What do I have to do now? I divide it? No. I square root it. All right. Squaring it, when I squared these values, notice it made them way bigger than even any of the original values were. Never mind the differences of those values. So squaring it made it really big. I averaged those squares, and now square rooting it is going to kind of bring it back down to a scale that is meaningful to the data. And when we square root the variance, we call that little sigma. That's also, right, standard deviation, which is the thing that we are looking for. Let's see. So let's figure out, I'll just call this sigma. So equals SQRT is the square root function for spreadsheets. Select that, enter. I get 39.37. Now, can someone tell me what that means? Yeah, you can use a calculator as well. What does that mean? Not to be confused with mean the average. No? Mean describes a measure of center, right? It's a single number that's trying to describe where is the middle of my data roughly. And there's mean, median, mode, those are types of measures of center. Standard deviation as well as range, those measure what? Of, no, that's what these ones are. Variation, close, yeah, close. All right, measures of variation. So what that's describing is how spread out is my data or how densely compact is my data. You could also view that once I get the standard deviation for this data set, I could then make an analysis and a judgment as to which of these stores is more consistent than the other. One that has a lower standard deviation will have all of its values more tightly packed towards the mean or the measure of center that we'd be using, and that would then be more consistent. Let's figure out what the standard deviation is for this other store. All right, 48.09 is what I'll round that up to. And so notice that store A earned less on average, but had a more consistent outcome. Store B earned more on average and had a less consistent outcome. All right, so this one was less consistent than the other store. Or in terms of this, the data is more spread out. Data more spread out. Okay, so that's what we end up seeing going on there. And so that's one of the values of measures of center is we kind of figure out, right, roughly what is a number that represents all the data. And measure of variation is telling us how broad is that data, how spread out is that data. All right, so yeah, so there's standard deviation. You will have the formula, but you'll have to set up your table in columns by yourself today. Let's see, let's keep cruising. Let's just look at macro themes today as best we can. It says, make a Box-and-Whisker plot that represents the data. Identify the shape of the distribution. Let's see. I I think it'd be helpful to organize it from least to greatest. You guys agree? 120, 160, 180. 6 is a little bit. There we go. 200, double 200. Yeah, 210. Double 230. Question. What is the mode? They didn't ask us that. I'm asking us that. Yes, 200 and 230 are the mode. Actually, let me highlight that in red. Right, because there's 2 of those and 2 of those. So this data set is what we would call bimodal. It has 2 modes. Right? Okay, so let's see. If I want to make a box and whisker plot, I need what is called the 5-number summary. Okay, 5-number summary. What is the lowest? 120. What is Q1? Actually, okay. Actually, wait. Let's answer Q2 first. Yeah, median or Q2. Both of those are the same thing. Okay. So when I'm figuring that out, I divide my data set into 2 halves. Because there were 2 in the middle, the median ends up being 200 plus 200 divided by 2. And that's going to be 200. The average of 200 and 200 is 200. All right? I did that math in my head. True. Like, seriously, this video is going to have so many people be like, watch this amazing mathematician average 2 numbers in his head. And, like, people are going to click on it all the time. Oh, man. Like, how did he do that? Like, and then I'll get interviewed by the local news. Oh, I guess. Yeah, they could argue that maybe they didn't see. All right, so now if I want to find quartile 1, how do I do that? So yeah, to find quartile 1, it's the middle number of the first half of the data. Okay? So what's the middle between those? Yeah, I'm just going to write 170. Right, average those. Take the mean between those. It's halfway between them. And yeah, what's Q3? Nice. Oh, let's see. Man, I guess I might as well try to stay consistent with my color. I just wrote, there we go. So Q3 is going to be between 210 and 230, is 220. And then lastly, what's the highest number? Okay, so let's organize this data in what we call a box and whisker plot. Here we go. Ooh, nice. Look at that. I already had a nice horizontal line for myself. So I need to start at least as low as my lowest number and go at least as high as my highest number, okay? All right. The range between those is like 110. Yeah, count by 20s, you're thinking? Yeah, I'll do that. 140. And when I'm labeling this, I want my spacing. This one's actually a little bit wider than that, but I'll live with it. 180. I try to space them out consistently. 220 and 240. Oh, I should have labeled those on the bottom side. That's all right. Okay, so my low number was 120. Put a dot. My quartile 1 was 170. Put a vertical little line. That's going to be part of my box. 200 is the median, or quartile 2. 220 is quartile 3, and the highest number is 230. Draw my box and whiskers. Right? There we go. And the special thing about box and whisker plots is this. How much of the data is between these two? Okay, all right, if you're so clever. What amount of the data is between these two? What? That's insane. That's insane. No way. Can't. What? All right. Oh, yeah. By the way, these numbers were representing masses in kilograms of lions. There you go. So one of the ways that once you have these 25% things analyzed, I can see that the data, because this is a very short width that is very dense around here, most lions, or a good chunk of lions, 25% of them, in fact, are going to be between there. I could even then combine two regions and say 50% of the lions are going to be between 200 and 230 pounds, and etc. The fewest lions are between these two. And actually, look at this. 120 is quite a ways off from the rest of them, right? The next lowest was 160 here. Right? Yeah. So this one is almost what we might call there we go, an outlier. Now, in terms of what we all know about lions, why do you think that might be the case? Maybe it's a baby. Oh, guys, it's a baby lion. I don't know. I think I could catch it in a Pokeball, but I might be wrong. Well, guys, I think that sadly that's all I have time for. Have a great day. Bye-bye.